All right, here's our video, chemical equations. And when we're talking about chemical equations, we're dealing with reactants and products. So when two or more chemicals come together, they will produce a product. So let's write that out. Let's use red. So we have our reactants. And they will yield, is that yield sign, a product or products, right? So this is I'll just put another arrow here to say that's the yield sign. Right? The yield sign, or so we're saying it'll make a product, right? It'll produce a product. That's what we mean by the yield sign. And you could see yield signs that go both ways, but we're not going to talk about that in this video right now. So the reactants are breaking down, right? The reactants are breaking down chemical bonds, right? Chemical bonds. And what do they want to do, right? They want to break them down to form new bonds, the products, right? All right, let's clear this out. Let's get a clean page going. So let's first make a chemical formula. So let's start with sulfuric acid because sulfuric acid is the number one product. It's the number one produced chemical worldwide. So let's write that down. Let's use blue. Why not? It's the number one. The number one produced. The number one produced chemical produced now. It's not the number one chemical, right? It's the number one produced chemical worldwide, not just in the United States, worldwide. And it's used in, well, you can find it in fertilizers, right? You can find it in fertilizers. You can find it, let's see, in detergents. They're in, of course, car batteries, right? That's the sulfuric acid in car batteries. They're in, and not the electric vehicles, but they're in, let's see, what else? They're in dyes. They're in explosives. They're in many things, right? So sulfuric acid is this. So here's where we'll start. We'll have hydrogen, and it has this subscript here. That's a subscript, the subscript, right? And you probably have seen the subscript in algebra, right? So it's just saying it has two hydrogen atoms. It has sulfur. It has four oxygen. All right, so that's sulfuric acid. And if you add water to this, so if we'll add H2O, that's water, right? Dihydrogen oxide. It's the chemical name dihydrogen oxide or dihydrogen monoxide. Mono meaning one. So if you add water, this is going to have a very violent reaction. So sulfuric acid and water. If you add water, it will react. It will vigorously react. Let's put that down. Vigorously react with water, with aqua, H2O, dihydrogen monoxide. And you're going to get a highly exothermic, you should know this term, exothermic reaction. So in other words, the heat is coming out. There's going to be extreme heat. So you're going to go anywhere from, say, 19 degrees Celsius, which is just about 66 degrees Fahrenheit. So let's put it that way. And it's going to rise to about 131 degrees Celsius, which is about 267 degrees Fahrenheit. You can see very high heat reaction here. And just looking at vigorously, that's not how vigorously spell. Let's use a red. Spell it right now. Big or then the us. That's it. A little better. Vigorously. And the subscript. Let's write that better too. Subscript. It's a little blurry there. There we go. And by the way, we're talking about in about 100 milliliters concentration of this. So 100 milliliters concentration of this. That's what you'll see this highly exothermic reaction. All right, let's clear this out. Clearing it out. And let's write the formula now. And we'll stick with red. Why not? So again, we have hydrogen, 2 hydrogens, right? We have sulfur, oxygen, 4 of those. And we're going to add it to hydrogen, 2 hydrogens, and oxygen, dihydrogen monoxide, water. And we're going to yield, we're going to produce 3 oxygens with 3 hydrogens. That is, oxygen has a little plus here because oxygen becomes a positive ion. And by the way, put another arrow. This is hydronium. Hydronium. Say hi to hydronium. And there's some people who claim hydronium has a lot of health benefits if you drink it. But I'm not claiming that. You can look that up. We'll have actually videos on this later. And also, we're going to have this. We have a hydrogen, we have sulfur, and 4 oxygen. Right? And this, by the way, is hydrogen sulfate. Hydrogen sulfate. So we have our reactants, which will yield, which will produce the products. And it's very important now to know about the law of conservation of mass. Let's look at that. Right? And in simple terms, and I'll write it down. What should we use? Let's use green. Right? The mass of the products, must equal, very important, must equal the mass of the reactants. So if you had this, let's say we had a scale here and we measured our reactants. It's a funny looking scale, right? And let's say that on the scale it read, let's say it just said 3 grams, whatever the case may be. Whatever was in this beaker, little beaker here of stuff. Who knows what this is? So, and let's make another scale. So when we yielded the products, like these are the reactants, we measured the reactants, we got 3 grams. And when we measure the products afterwards, get our little color ready. There we go. And who knows, maybe it has a different color, right? Now we have the, and then what should it weigh? 3 grams, right? That's the mass, should be the same. So again, this is very important, keep that in mind, because when we're doing chemical equations, whatever elements you used in the reactants and how many you used should appear in the products. And we'll give examples of that. So let's do that. Clear this out. Go back if you need to. All right. So we're going to have a chemical, well, a vocabulary alert, that is, like a chemical vocabulary alert. Unbalance and balance is very important, and I'll explain that as we go on. So let's just take a chemical equation. So what should we use? Let's use that color. Whatever this color is, magenta or something. So let's say we had aluminum, or aluminium, as a lot of the world says. That's aluminum. So I'll write it up here, aluminum. Let's say aluminium right now. Kind of like that. So aluminum plus iron oxide. Iron oxide. And here's iron oxide. What is that subscript? Again, there's 2 of these as the iron. And here is the oxygen, there's 3 oxygens. And it will produce iron plus aluminum, 2 of those aluminums, and 3 oxygen. Now, this is a chemical equation, but it's unbalanced. So let me explain first why it's unbalanced. And then we'll balance them. So why? So if you look at aluminum over here, there's 1 aluminum here. I'll use another color. There's 1 aluminum here. There's 1. But over here in the products, there's 2. See the 2? So it's unbalanced. That's why it's unbalanced. What else do you see unbalanced? All right, so what else do you see? So look at this for iron. There's 2 irons over here, but yet there's only 1 over here. So again, unbalanced. What is fine by what stays the same? The oxygen. Look at the oxygen. There's 3 oxygen, and then there's 3 oxygen. By the way, if you want wondering, O3 is ozone, that stuff in the stratosphere that protects us from ultraviolet rays, right? And again, if you're getting confused with these subscripts, we're just saying that there's 3 oxygen molecules together, right? There's supposed to be zeros or O's, so that's oxygen, right? And then let's say we have 2 aluminums, right? 2 aluminums together, but over here we have just one iron. So again, let's go over this again. So if you look at the reactant side, the reactants, there's only 1 aluminum, but the product has 2, so it's unbalanced. In the reactants, you have 2 iron, but in the product, you have 1. So let's see how we can fix this. So in other words, another vocabulary word you should know is coefficients. You learn this in math, right? Coefficient is the number, like let's say 2 next to a variable. In chemistry, though, it'll be a number next to an element, like aluminum, right? Aluminium. All right, so let me erase this. Let me erase this out over here. Let's make it easier. Oh, why don't we let's do it over. Let's clear it out. I'll write it over. All right, let's just do it over so you make it clearer for you. So I'm going to take aluminum, aluminium, whatever you want to call it. We're going to take the iron, which has 2, the oxygen, which has 3. It's going to create iron plus 2 aluminums and 3 oxygen. So we said before, over here we have 1 aluminum, but over here we have 2 aluminum. So we're just going to balance out aluminum first. We do one at a time. So right now, this chemical formula, this chemical equation is unbalanced. So to balance it now, we need 2 aluminums over here. So that's where the coefficient comes in. Now I'm going to say 2 aluminum, right? Plus, we'll just keep everything the same right now. And it will yield the iron, 2 aluminums, or aluminium. So now the aluminum is balanced, but the iron is not balanced. Do you see it? And we'll change the color to make it easier. So now we have to balance out the iron. So how can we do that? Well, we already balanced the aluminum, so keep that. We can't touch anything here because we have 2, so we need 2 over here. And how do we get 2? Use the coefficient. Now we have 2 iron, and let's see if this is balanced now. We have 2 aluminum over here, 2 aluminum, 2 aluminum, 2 iron, 2 iron, 3 oxygen, 3 oxygen. This is balanced. The law of the conservation of mass stays the same. Now, we'll do a few so you understand this. Okay, clear it out, go back if you need to. All right, so let's take mercury oxide. Mercury oxide. And you guessed, you have mercury and oxygen involved in it. So here's our mercury, Hg is mercury, and we have oxygen. And it's going to yield, and before I go any further, you will see, when you see this, you're going to see this delta symbol on top of the yield sign. So that's the Greek word delta, Greek letter delta. In math, you would have seen it as meaning the change of when you've done slope. Remember in algebra? But for chemistry, that just means that you have to supply heat. So this reaction won't work without heat. So heat has been supplied, and you will get mercury plus 2 oxygen. And by the way, O2 is what we breathe. We breathe in O2. All right. Now, is this balanced or unbalanced? So it's unbalanced, right? It's unbalanced. Why is it unbalanced? Well, let's just look here on this side, and we'll go back to that magenta color, whatever it is. There's only 1 oxygen over here, but there's 2. So how can we balance it? So if we say 2, remember, always use coefficients. Don't use subscripts. Don't add subscripts. Just remember that. And don't be so concerned of why this is happening. We're just showing the equations. In other videos, we'll explain a little more about it. So now we have to put a 2. And the reason why we're putting it next to mercury is because they're together. That you don't see a plus or minus. Can't separate that. And it will yield. And we put that delta sign, meaning we have to add heat. And we have our mercury plus our oxygen. Right? Now, there's another problem. Right now, this 2 is telling us we have 2 oxygen now. Right? Because this mercury and oxygen together, they're together, right? It's not separate. It's not separated by a plus or minus. They're together, so we need 2 of them. This is still unbalanced. Why? Still unbalanced because we have 2 mercury over here, but only 1 over here. So we have to fix that also. So we use green. Why not? Have to fix that. We have a whole delta sign. And we have to put a 2 here. Now it's balanced. Is it coming together yet? We'll do a couple more. You'll get used to it. All right, let's get another one going. Clear this out. All right, so what if we had, use purple. Let's take magnesium now. Magnesium. So that's Mg. And we'll add it to that. You should know by now what O is. Oxygen, right? So magnesium and oxygen. And remember, magnesium and oxygen, they are the reactants. They are the reactants. And we want to yield. What do we want to yield? Magnesium oxide, right? Magnesium, fix that S, oxide. So it will yield magnesium and oxygen. Something's going on here. It's unbalanced. Why is it unbalanced? Well, we have 1 magnesium here, and we have 1 there, so that's fine. But we have 2 oxygen over here. Well, here we only have 1. So why don't you try to balance it? Okay. Pause the tape if needed. So what did we do here? We know why it's unbalanced. So if we said this, so we kept the magnesium, because magnesium is not a problem, kept the oxygen, there's no problem there. And then if we did this, now we have 2 oxygen. But now we have another problem. What's the other problem? As we're getting a call for more questions. So we have 2 magnesium now, so we have to fix that. So again, don't be too concerned of why this is happening. Just look at what needs to be balanced. Right? So to fix this, and we'll put green now. Now we need 2 magnesium because we have 2 over here. We have our O2, and that will give us the 2 MgO, magnesium oxygen. So now it's balanced. Excellent. All right, let's write balance down. Let's do a few more so you get used to it. All right, let's change the pen. Let's use this color. So if we took this one, if you can do this one, then I think you're getting it, right? So if we took this, we'll take 6 CO2 plus H2O. That's the reactants. And we will yield, we'll get a product, we'll make this. 6 carbon, 12 hydrogen, 6 oxygen, plus O2. By the way, change it to blue. This right here, this arrow right here, this is glucose, which you should be familiar with. The energy that our body needs. We want glucose. The body prefers glucose. But anyway, let's make this chemical reaction. Let's see. Why is it unbalanced? Why is it unbalanced? So this is unbalanced. So why? Right? Well, here we have 6 carbon, right? But we also have 6 O2. So we have 6 O2 molecules. So there's 1, there's 2, there's 3, there's 4, there's 5, there's 6. So we have 12 oxygen. And over here, we have 6 oxygen. And then here we have 2 oxygen, but here we have 1. So you can see it's unbalanced. So we should fix one at a time. So let's fix the carbon first. Right here, this carbon, right? So let's fix that first. So we had 6 CO2. So we know we have 6 carbon. And over here we have 6 carbon. So we don't have to do anything to carbon. Carbon's complete. But what about the oxygen now? Let's look at the oxygen. Like we said, we had 12 oxygen over here plus 1. Here we have 6 and 2. So let's fix the oxygen next. So how can we fix the oxygen? So let's use blue. So we have H2O. We know we have 12 oxygen over here. Let's look at that first. How can we get 12 oxygen over there? Well, what if, and we'll keep this, do one at a time, look around, it's like a puzzle. What if we added 6O2 over here? What would that give us? That will give us 12. So now we have 12 here, 12 oxygen. Remember, saying we have 6, the coefficient is saying we have 6 O2s. 1, 2, 3, 4, 5, 6. There's our 12. There's our 12 there. So is it balanced yet? We have 12 oxygen here, but we have 12 oxygen here, but we have 6 here. So we have 6 here, but here we only have 1. So it's not balanced yet. So let me clear this out. Let's get a bigger page here. Clear it out. Pause the tape if you need to. So we started with 6 CO2 plus H2O, and we yielded glucose. Remember we said this glucose, 6 carbon, 12 hydrogen, 6 oxygen, plus 2 oxygen. And then we said to fix it, right? To fix it, we're going to say 6 CO2 because we have to balance it. That's what I mean by fixing it. And we kept that the same so far. We had this, and we added 6 here. Now we have 12 here and 12 here. But oxygen is still not balanced because on this side, like we said, on the right side, there's 6 where I'm pointing. You might not see that, right? So there's the 6, but there's only 1 there. So we're going to fix that. How should we fix it? Well, if we said 6 CO2 plus 6 H2O, now let's see if this is balanced. Do one at a time. Take your time. Just do one element at a time. You should be okay. So let's see if this is balanced. So here we have 6 carbon. There's 6 carbon over here, and there's 6 carbon over there. So carbon is fine. There's 12 oxygen, because we have 6. 12 oxygen. Plus here now we are saying 6 oxygen, so this gives us 18 oxygen. We have 6 O. 12 plus 6 is 18. And over here we have 6 oxygen plus 12. 18. Oxygen is balanced. Now, if hydrogen is balanced, we have a balanced equation. Do you think it's balanced? Let's use a different color. Well, over here we're saying we have 6 H2s, which would be 12 hydrogen. And right here we have 12. We just balanced it. So this is a balanced chemical equation. So rewind if you need help, post if you need questions, and that's our video for today.